Well, guys, in this video, we will try to cover some examples so that you can relate with the questions, so that you can feel the improper integrals properly. Uh, improper integrals properly. What a line. So basically, let's talk about exam. Let's say this is 0 to infinity. Sorry, 1 to infinity. 1 by x cube dx. Now, in that case, you can see here the upper limit is infinity. That means it is type 1 subtype 1. Now, using the basic integration, like this is basically nothing but x to the power minus 3. Using the basic integration rules, you can easily solve that question. But we have to solve it using the definition. Basically, you have to see that does the integral converge or not. So basically, what you can do here, you can see first the step is limit b tends to infinity 1 to b, this is x cube dx. Now use the simple integration rules. So this is basically x to the power minus 2 by minus 2, 1 to b. Now this is basically minus 1 by 2x square, 1 to b, limit b is tending to infinity. This is minus, this is 1 by 2 b square minus 1 by 2 with a limit. Let's say I'm putting the limit at that point. I mean here, because you can see it now. Now basically this is limit b is tending to infinity by 1 by 2b square plus half, right? Now the answer is, if we are putting v is infinity, then you will get 2 into infinity square, which is 2 into infinity means infinity. The 1 by infinity is basically 0. So the answer is half. You can easily solve it using the basic integration method, but using the definition you have to solve. And first of all, you have to write something at the beginning, which is basically like you have to write from the definition, we can say, or we can replace infinity as b or something like that. You have to write so that your statement should be more logical and more acceptable. Okay, this is the point of view. And at the end of the day, you have to write at at the end we will get a constant which is half, and as we will get a constant, that means I will converge or something like that, or I converges, or you can say I will exist, or you can say I will not diverge. This kind of statements you have to write, so that you can get full marks, because statements is too much important more than even the process. If we are not writing the statement, and even you have to write why this integration is an improper integration, because first of all we have an infinity at the upper limit, that's why it is an improper integral. Now basically let's talk about another example so that you can also relate. In that case, let's say minus infinity to infinity e to the power minus x square x dx, using the even odd property, which is basically f of minus x is equals to minus of fx. You can see here, right? Because if you are putting f of minus x, then e to the power minus of minus x whole square into minus x, which is nothing but minus e to the power minus x square into x, and this portion is fx, so this is minus fx. So the answer is 0, right? So the answer is 0. Because if we can say that, let's say this is fx dx minus a to a, the property is like if f of minus x equals to f of x, I mean this, sorry, minus, what I'm saying, f of minus x is equals to minus of fx. In that case, we can say this is nothing but f of x plus f of minus x 0 to a dx. You can see here, if we are adding both of them, basically we are adding f of x both sides, then we will get, this will be becoming 0, this will be becoming something like that. So we can say f of x plus f of minus x is equals to 0. So this portion is 0. So the answer is 0 dx, 0 to a, which is 0. However, but we have to solve this integration using the definition. So you have to write first, because we have two infinities at the upper limit and at the lower limit respectively. Basically, up at the upper limit we have an positive infinity, and at the lower limit we have a negative infinity. So basically, how will we deal with that? So first of all, you can see here the function is changing its sign at 0. Basically, let's say this is 0, the function is something like that. So it is changing its sign at 0. Sorry for a mistake, the function is not like that. Function is something that basically it will pass from the origin. You can see here the function is changing its sign after 0. So we have to break the limit, something like that, minus infinity to 0 e to the power minus x square x dx plus 0 to infinity e to the power minus x square x dx. Now we have to solve this and this integrations separately. Now let's move on to the next page for solving it properly. Now you can see this is minus infinity to 0 e to the power minus x square dx and x. This integration, let's say I dash, and basically we have to take a limit. This is type 1 subtype 2, where the lower limit is tending towards minus infinity. B is tending to minus infinity, let's say. This is b to 0 e to the power minus x square x dx. This is I dash. Now solve this. How will we solve? We have to take a minus half. This will be e to the power minus x square into minus 2x dx. It is very easy to solve. I am using the direct method, or you can say D method. This is b to 0. This is e to the power minus x square d of minus x square. Now this is minus half. This is e to the power minus x square with the limit 0 to b. B to 0, sorry. Now this is e to the power minus 0 square minus e to the power minus b square. Now it is basically minus half, and it is basically 1 by 2 e to the power b square. Now I have to put the limit, which is limit b tends to infinity, minus half plus 1 by 2 into e to the power b square. Now you can see e to the power b square means e to the power infinity square, which is basically infinity, and 2 into infinity is again infinity, so 1 by infinity is 0. So this term will be 0, and the answer is minus half, and this is for the answer, this is the answer of the first integral. Okay, the first integral is basically nothing but minus half. Now let's talk about the second part, where we have to deal with the improper, an improper integral, where the upper limit is infinity. Now the solving procedure will be same. Just you have to take another constant, let's say a, which is tending towards infinity, 0 to a e to the power minus x square. Now I am doing a simple and single step jump. Basically this is nothing but minus half into e to the power minus x square. A 0 limit a is tending to infinity. Now you can see this is e to the power minus a square into minus half plus half with a limit a is tending to infinity. Now this is basically 0. Why? E to the power minus a square means 1 by e to the power a square, which is basically nothing but 1 by infinity, and 2 into infinity means half into 1 by infinity, again 1 by infinity, which is 0. So this will be 0. The answer is half. Now we have to add I prime and I double prime, because wait a moment. You can see here we have to add both of them, right? There is a plus. So let's add both of them. Hopefully it is visible. I prime is minus half and I double prime is half. So this is minus half plus half. So the answer is 0. Hopefully you can understand the full question, and basically you have to solve this kind of question in that way. And definitely this question is very like very big to solve, very longer, very lengthy questions, but it is the only way. Like if you are talking about definition, then you will see like when we are talking about any kind of definition, or when we are doing any kind of sum or any kind of integration using the definition, then it will become too much lengthy, and that is the fact. You can't ignore it or something like that. Let's move on to the next question, where we will talk about type 2. In type 2, uh, we will deal with a function which is, let's say, 1 by x dx 0 to 1. Now in type 2 we have to deal with some functions where the functions are not bounded in the region at any point. In that case the function is not bounded at 0. So how we can deal with that? I had told you we have to take a epsilon which is very small, but it is positive number. You have to write epsilon as a positive number. Epsilon is the positive number which is basically epsilon greater than 0 and epsilon less than 1. 1 means not actually 1, it is 1 minus 0. Basically the subtraction of upper limit and lower limit. Well, so epsilon less than 1, greater than 0. And this is now 0 plus. And why we are adding epsilon with 0? We can subtract also. No, we can't, because we have to stay on the region between 0 to 1, right? 0 to 1. We have to stay between 0 to 1. If we are subtracting epsilon from 0, then we will not be in the region from 0 to 1, right? That's why we are like adding epsilon. Okay, fine. Now this is limit epsilon tends to 0 positive. This is epsilon, this is 1, this is 1 by x dx. Now you have to know the basic integration. This is ln x with a mod, but as we are talking about 0 positive, like let's say we are talking about 0 to 1, that means x will not be negative, so we should not take about, I mean we should not take mod. We should not take means we can take, but doesn't matter. If we will take, then also doesn't matter. I mean the mod will be cancelled out or something like that. Basically this is 1 to 85, I mean epsilon, sorry, limit epsilon tends to 0. So this is ln1 which is 0 and minus ln epsilon limit epsilon tends to 0 positive. Now we are talking about 0 positive. So let's talk about the graph of ln x. The graph of ln x is looking like something like that. This is ln x. Okay. Now when we are talking about 0, this is y-axis, I mean specifically negative y-axis, and the graph of ln x will meet at infinity. No, we are talking about minus y-axis, so it will meet at minus infinity. The distance is infinity, but you are talking about minus y-axis, so the actual answer is minus infinity. So when we will put epsilon is equals to 0, then it will be become minus infinity, but as there is a minus symbol, so the answer is positive infinity. And you can say now the integration is not converging at a point or at a value. That's why the integration diverges, or you can say not exist, or you can say it is not converging or something like that. So it is very easy to solve. Now move on to the next question, where we have to solve type 2, subtype 1 and subtype 2 both. So let's talk about the next question. Well, basically I'm taking this function from -1 to 1. Now you will see you can easily solve it using the even odd property, where you can see f of minus x is equals to minus of fx. This is one of the beautiful example of this question. I mean, what I'm saying, basically in that question you will see the answer is not 0. Using the even odd property you can say the answer is 0, but for a special case or for a special principle the answer is 0. Otherwise, if you are solving gradually or generally, the answer is not 0. Now why answer is not 0? Let's solve with the definition. So first of all, you can see this is -1 and this is 1, so there is no infinity at the lower limit or at the upper limit. So you have to talk about the type 2, where the function is not bounded at the region. So you can see function is bounded at -1, function is bounded at 1, but the function is bounded, I mean is not bounded at 0, which is between -1 to 1, which is lying between -1 to 1, right? So you have to break the limit into two parts, where -1 to 0, 1 by x cube dx, plus 0 to 1, 1 by x cube dx. So it's very easy to understand. Now what we can do, this is type 1 subtype 2 and this is type 1 subtype 1. So let's solve this. Let's say this is I prime and this is I double prime. Sorry. So let's move on to the next phase for solving it properly. You can see here this is -1 to 0. Hopefully it is visible. Now basically we have to take let's say limit epsilon tends to 0 positive. This is 0 minus epsilon, because you have to stay in the region between 0 to -1, right? Sorry, -1 to 0, whatever, doesn't matter. This is x cube, this is dx. Limit epsilon tends to 0 positive, and this is basically nothing but -1 to minus epsilon 1 by x cube dx. Now it is very easy to solve. This is nothing but x to the power minus my 2 into x square. There is a minus 1, -1 to minus epsilon, limit epsilon tends to 0 positive. Now we can easily solve this question. This is limit epsilon tends to 0 positive, 1 by epsilon square minus plus 1 by 2. Well, this is the answer of I prime. Now we are not solving. Basically, if we are solving, then we will get a kind of infinity or something like that. This will not exist. Basically, if we are putting epsilon is equals to infinity, epsilon is equals to 0 positive, then we will get an infinity. Because let's say we are talking about in epsilon square. So epsilon square will be always positive. So 1 by a very very small number which is tending towards infinity, and there is a minus symbol, so the answer is minus infinity plus half, which is basically again minus infinity, right? Because half can't do anything. It is like negligible quantity in front of minus infinity. So the answer is, let's say the answer is not exist, looking like something that. Now talk about I double prime. In I double prime, we have to deal with 0 to 1 with same function. Limit, we have to take another constant, because we had taken epsilon already. So we have to take another constant. Let's say this is delta, 0 positive, 0 plus delta, sorry, because we have to stay on the region which is between 0 to 1, right? X cube dx. Now it is very easy to solve. This is nothing but minus 1 by 2x square. Delta to 1, limit delta tends to 0 positive. This is limit delta tends to 0 positive. This is minus half plus 1 by 2 delta square. Again, I double prime will not also exist because this is minus half, this is positive infinity. If we are putting delta is equals to 0 and delta square means uh, again it's a positive number into 2. So basically 1 by very small number which is basically tending towards infinity. Now again minus half is nothing in front of positive infinity because it's a negligible quantity, right? Like if we are talking about infinity, so we can say that minus half plus infinity is infinity, so it will not exist also, not exist basically, not exist. Now not exist plus not exist is equals to not exist, like I prime plus I double prime equals to not exist, and you have to write it in your exams if this question will come. It's important, right? You have to write everything like in statements, not like that I prime plus I double prime equals not exist or something like that. You have to write in through statements. You have to explain. Now after that, how will we solve? Well, I had told you there is a kind of principle which is very special principle for this kind of questions, which is called Cauchy's principle. What the Cauchy's principle is saying to us, it is saying that epsilon is tending to 0 positive and delta is also tending to 0 positive. Both of them are less than 1. So we can take this for this kind of integral only. This kind of integral only. You can use the Cauchy's principle in type 1 also. It depends. Like in the previous question, not in the previous, I mean, where we had taken, I mean, we had breaked the limit. Uh, I mean, what I'm saying, Cauchy's principle is basically like you can use it for type 1 also. Wait a moment. In that question, we had taken minus infinity is basically nothing but b is tending to minus infinity and a is tending to infinity, right? We can take a is tending to infinity, but this will be becoming minus a to 0 and this is same 0 to a. Hopefully you can understand, right? Let's move on to the main question. Now if epsilon is equals to delta, so we can replace epsilon with delta. So I prime will be equal to limit delta tends to 0 positive, this is minus 1 by 2 delta square plus half, and I double prime, if we are adding both of them, then it will be limit epsilon, delta tends to 0 positive 1 by 2 delta square minus half, right? Now you can see both will be cancelled out and the answer is 0. But you have to write something which is when we are using the Cauchy's principle, then the answer is 0. Otherwise the integral will not exist or will not converge or it will diverge or something like that. You have to told, and you have to explain the whole integral through statements. Be careful about that. You have to write everything so that examiner will give you full marks or something like that if you want to get full marks in that question, because this is very easy question, but you have to write something so that examiner will understand, or examiner will not like say what you have written, man, or something like that. Okay, be careful about that question. Maybe this question will come. It is very important and very powerful concept, which is Cauchy's principle. Now let's move on to the very hard question. Too much hard question. I am using too much infinite times. So it's very hard question, and the question is about a beautiful concept which is called absolute convergence. We will solve this integration. Actually, we will not solve. We will talk about the divergency or convergency of this integral. Basically, using the Feynman's trick, or basically the name is basically like differentiation under integral, we can easily solve that question. We will take around 5 minutes to 6 minutes to solve that. But we have to talk about the convergence or divergence. I know, maybe, I don't know. I don't want to expose even. However, maybe it will diverge, maybe it will converge. It depends. Because, like, the differentiation under integration, this process or this theory is not well established. So be careful. Now let's talk about this question, the convergency or divergency. Let's move on to the next page. It is very, very important and a very, very hard question. So please pay your kind attention carefully to that question. It is very, very important question. Now let's move on to the next page. So basically you have to deal with this integration. Now there will be two approaches for testing the convergency or divergency. First of all, Cauchy's criterion, and Cauchy's criterion where we have to deal with x prime and x double prime, or we have to deal with another capital X, which is basically a kind of positive number. But it's too much hard to deal with the Cauchy's criterion because it is too much complicated. So we will deal with the absolute convergence, like note it, like if, let's say this is I, and I prime is basically mod of 0 to infinity sin x by x dx. If this will converge, then I is absolute converging. If I double prime, which is basically 0 to infinity sin x by x, then I will converge. Not absolutely, but I will converge, because actually this is not possible. Absolute convergence is not possible in that question because we can't integrate it. So first of all, it's the problem, and hopefully you can understand the question. Now we have to solve this question, this portion, or I double prime, so that you can say that the I is converging, but not absolutely. Definitely it is not absolutely converging, but it is converging or something like that. Or maybe it is diverging, it depends. I'm not exposing. Let's say it is diverging or converging, I don't know. I have to do the sum so that I can relate. I mean I can say that it is converging or diverging. So let's solve the I prime. Basically you have to solve I prime. If I prime will say us that I am converging, then I will say that I am also converging. So I prime is 0 to infinity sin x by x mod dx. Now we are talking about 0 to infinity. Basically we are talking about positive numbers. So we can say that mod of sin x by x is basically nothing but mod of sin x divided by mod of x. And as we are talking about the positive numbers, we can say mod of sin x by x. We can neglect the mod of x part only. Now this is 0 to infinity sin x with a mod and x without a mod dx. Now let's say that limit n is tending to infinity, and this is n pi. And why we are taking n pi? Because sin x is an oscillatory function where we have to deal with pi, and we are taking only this portion. Like let's say this is pi, this is 2 pi, this is 0, that does, so blah 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 blah. Now this is mod of sin x with a mod and d. Okay, fine. Now be careful. Okay, it is very dangerous question. Well, we can say this is, we are neglecting the limit at that moment, just neglect it. We can say this is r equals to 0, sorry, not 0, 1 to n r minus 1 into pi to r pi sin x x. How we can say? Let's put r equals to 1, we will get 0 to pi. Let's put r equals to 2, we will get pi to 2 pi, dot 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 dot, we will get at the end of the day n minus 1 into n pi. We are basically breaking the limits. Now we can sum it to 0 to n pi, right? We can say this is basically nothing but the summation of n pi. So we can say this, this is equals to this. Now let's take a substitution x equals to r minus 1 into pi plus t. And why we are taking this substitution? Because we have to make this lower limit 0 and this lower limit pi, and this is the only approach. Now dx is equals to dt, and what will be the limit? You can see here, if we are putting x equals to this, then the limit will be 0 with a summation r equals to 1 to n, and this will become pi. Well, very nice. This is sine x, sorry, sine r minus 1 pi plus t with a mod divided by r minus 1 pi plus t dt. Now basically look at that, this is also important. We can say this is sine t with a plus minus 1, maybe this is minus 1, maybe this is plus 1, doesn't matter. I mean, it matters, but actually it doesn't matter, because we can say this is minus 1 whole to the power r minus 1 with a mod into mod of sine t. Now this will be 1 or minus 1, both of them will be converted into 1 because there is a mod. So the actual answer is sine t of this portion, right? I mean mod of sine t, sorry, mod of sine t with a mod. So this is a summation n 0 to pi sine t by pi to r minus 1 plus t. Now we can neglect the mod of sine also, because we are talking about 0 to pi, and 0 to pi means we are talking about first and second quadrant, right? At the second quadrant, sine is positive always, so we can neglect the mod always. And at the first quadrant, definitely all trigonometric functions, like all sine, tan, cos, all will be positive, so we can neglect the mod, right? Now let's move on to the next page. Wait a moment. Okay, fine. Now let's move on to the next page for understanding this integral property. Now I am taking an inequality which is called this. Let's say can we say that? Definitely, because t is tending to, I mean not tending to, I mean t is from 0 to pi, so you can neglect t, and we can say like this is r pi minus pi plus t less than equals to r pi. Now you can see here t is from 0 to pi. Why we are talking about this less than equals to? Because t is 0 to pi. So let's say t is 0, so r pi minus pi, and let's say t is pi, so this will be r pi. So we can say if this term, let's say r minus 1 into pi plus t, it is nothing but less than equals to r pi. Maybe it will be equal, which is basically when t is pi, t is in its maximum, then it will be equal to r pi, otherwise it will be less than. So you can say something like that. So using this inequality, we can say r minus 1 into pi plus t less than equals to r pi, right? Now 1 by r minus 1 into pi plus t greater than equals to 1 by r pi. Why? What is the reason? Basically, if we are saying 2 less than 3, so 1 by 2 greater than 1 by 3, right? Now basically we can say this is, let's say sine t, we are multiplying sine t at the both side, and as sine t is positive, so inequality will hold. Very nice. Now integrate 0 to pi. So you can say this is maybe equals to or maybe greater than sine t by r pi. Now let's solve this integration. So we can say we can multiply r by both side. So this will be sine t by r minus 1 into r pi plus t, 0 to pi r pi greater than equals to this. This is basically sine t with a dt. Sorry for a mistake. Sine, the integration of sine t with respect to dt is minus cos t. So minus cos pi plus cos 0. This is nothing but sine t by r minus 1 into pi plus t greater than equals to, with the integration 0 to pi, this is nothing but 2 divided by r pi. Now we have to talk about the summation, because we have to find out this, not this. We have to find out r equals to 1 to n 0 to pi sine t by r minus 1 into pi plus t dt. We have to find this and full. So we have to talk about the summation also. Let's talk about the summation part. This is summation r equals to 1 to n, and this is summation r equals to 1 to n. Now basically this is the actual integral, which is called I double prime, right? I double prime is greater than equals to, you can say this is 2 by pi into nothing but 1 by r equals to 1 to n. Now if you know about zeta function, this is basically r equals to 1. Basically this is 1 by 1 plus 1 by 2 plus 1 by 3 dot 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 dot. Okay, 1 by infinity. If you know about the zeta function, then you know basically this is the summation of 1 by n to the power 1, where n is equals to 1 to n. But wait a moment, I had told you that we are talking about limit n tends to infinity. So basically we can replace n as infinity now. Basically this is the zeta function, where zeta s is 1. Acha, okay. Basically zeta s is 1 by n to the power s with a summation n equals to 1 to infinity. It is the normal format. It has an integration format or multiple formats. Riemann zeta function it is called. It is called Riemann zeta function. So s is basically nothing but 1. Now zeta 1, the value of zeta 1 is infinity. Why? Maybe you will say why it is infinity? Zeta 1 is like you can say it is tending to this. So the area is this, and like it is basically the curve of 1 by x, right? The area is tending towards 0. I mean, not area, what I am saying, the area is not 0, but we will say that the area is not infinity. But hopefully you can't understand one thing, which is we are not talking about the area, we are talking about the summation of 1 by r. Like let me introduce you all with a formula, which is zeta s is equals to 2 into pi to the power something, I don't know, I have forgotten the exact formula. Basically there will be a time of 2 pi 2 into pi into sine something, and there will be a gamma s and gamma zeta 1 minus s. Now if we are putting zeta 1, then the value will be constant. This will be treated as constant. So let's say constant k. And gamma 1 means 0 factorial, which is again 1. So constant into 1. But this is zeta 0. And zeta 0 means, if we are talking about this function, then zeta 0 is nothing but 1 plus 1 plus 1 dot 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 infinity times. So it's equals to constant into 1 into infinity, which is infinity. So zeta 1 is infinity. Be careful about that. So we can say that I double prime is tending to infinity or something like that. Basically I double prime is not converging, or basically I prime diverges. As I prime diverges, So I, which is the main integral, which is basically 0 to infinity sine x by x dx, it is also not converging, it is also diverging. So the final answer is not converge, just not converges. Hopefully you can understand. This is all for today, and this question is too much hard, so be careful. And if you can't understand, then pause the video, or you can say, you can rewatch the video from the starting also. In this video, I tried to cover the comparison, I mean, the type 1, type 2, and the special integral. This is one of the special integral, this is. But three things we hadn't covered yet, which is comparison test, mu test, and limit test. In the next video, I will try to cover the comparison test, limit test, and mu test, which is where the mu test is too much important. So thank you for watching my videos, and if you want to subscribe, then subscribe. If you want to like, then like. If you want to comment, then comment. And thank you. Goodbye.